the next one I'm going to show you is called the power rule. So we're going to be, here's how the power rule goes. So the power rule. Okay. And how the power rule goes is we're going to take the limit. I'm going to get us a new blue marker because this one's getting a little difficult to see. So the limit as x approaches a, should be easier to see, I think. Okay, so the limit as x approaches a of, and then we have, I have some kind of function inside of here, and then I'm going to take its power. So let's do this, right? So if I have a function, right, and it's going, you know, it's a function that's to a power, but this is all inside a limit. I'm taking the limit of this whole thing. Okay? Then what am I going to get? I'm actually able to do the power afterwards. So this is going to be the limit as x approaches a of, and then I have my f of x inside of here. And then I can do my power on the outside. So I can take the limit and then do the power. Okay? Where this n is a positive integer. Okay, so this n is a positive integer. It has to be a positive integer. Okay? So let's do an example over here. And I'm going to give you kind of a new suppose. So we're going to suppose that, so now we're supposing for the next example that we're going to do, we're going to suppose that we have, so we have f of x equals x, and we have n equals 3, and we have a equals 2. Okay, so then I'm going to have that, this is going to give me that, so that I have that the limit as x approaches a, right, of f of x is going to equal, so this is the limit of, right, this is the limit as x approaches 2 of x, which is just going to equal 2. In this circumstance, I'm just able to plug it in. Okay. So then this is going to give me what, like in my example, you know, as an example, the product, the power rule, sorry. This is going to give me the limit as x approaches 2 of, right, so my f of x to the n, so I have my x to the cubed, so x cubed. And that's a positive integer, so that's an okay example to use. So this is going to equal, well, right now this is like an x cubed is what I'm taking the limit of, but I could just take the limit as x approaches 2 of x and then cube it. So let's go ahead and do that. So I have the limit as x approaches 2 of x and then cube it. So just using the fact that we've computed that limit there already, we know that we're just getting from here, we're getting 2, right? This 2 goes in here. So we just get 2 cubed, which is going to equal 8. Okay. So again, I can just pull that power basically to the outside. Okay. So we used in our example, right? So this example we had here, so we used in the example, so we used in this example the fact, right, we used that, so here's rule 8, which is actually that the limit as x approaches a of x is going to equal a. It's kind of easy to see if you actually look at the graph of the function. Okay, but it's also a rule. So that's another rule that we have here. And the power rule example actually shows how to generalize the power rule. Okay, so this is in the power rule example. In the power rule example over here, we use that fact. And then this example is going to show us how to generalize the power rule. Okay, so, and the power rule example shows how to generalize the power rule to, so here's the rule, which is that when we get the limit as, well, yeah, okay, as x, well, it's not actually generalizing it. And the power rule example shows how to generalize, you know, how to, this is actually bad wording, so how to combine, yeah, I don't like my wording there, so it's just kind of very set. So, okay, so how to combine, so we're combining really 6 and 8, so 6, right, so 6 and 8 to get, so here's kind of a new rule, which is, you know, you could almost guess what it is at this point, which is going to be the limit as x approaches a of x to the n, right, where this has to be a positive integer. It has had to be, so as long as that's a positive integer, that this is actually just going to equal a to the n. So this is going to equal this a that's coming from there to this nth power. Okay, where you're just plugging a in for x is what you're really doing. Okay, so let's just kind of go through these. Some new rules. They basically say, when it comes to limits, you can do everything you want to do. If I'm taking the limit of a product, I get out the product of the limits. If I'm taking the limit of a quotient, I get out the quotient of the limits. If I'm taking the limit of a power, I take the limit, then I take the power. And then the other key thing that kind of comes into play here, when I've just got x, I can put a in for x. And then you can kind of see, you know, combining these two things that actually, like as we did in here, that actually gives you this rule here, where I can do that with any power of x also. Okay, so I hope that made some sense, and I'll see you in the next lecture.